Hey Algebra 2, here are your notes for lesson 7.4, talking about roots of real numbers, and we're talking about more than just square roots. So, starting off with our bell work, what is a root? Well, you probably each have your own kind of conceptualization of what a root is, but if you're looking for a legitimate definition of it, essentially it is this: a root of, root of x, let's say root of x, is a number that, when multiplied by itself, a certain number of times, we don't necessarily know, the second root would be 2 times, the cube root would be 3 times, yada yada, when multiplied by itself equals x. So I'm not going to write all that extra stuff down, but it's good to know. So how are we going to use this definition? Well, we've already talked about square roots a little bit. We're going to talk about those more in depth, but we're also going to be talking a little bit about cubed roots and this idea that you can either take x times x to get x squared, or you can take x times x times x to get x cubed, and that can create a cubed root, something else to work with. But before we get into that, how would a person go about finding the volume of a ball? In case you don't know the formula for the volume of a sphere off the top of your head, it is 4/3 pi r cubed. If we're talking about volume, obviously we're going to be talking about cubed. So, how would you then find the radius of a ball if the volume was 100 cubic feet? Now, I know this is only a bell work, but I'm going to go into that same method that I always do. I'm going to write down my knowns. It says the radius is unknown, but I know that the volume is 100. And I'm going to start solving. So if I know volume's 100, I'm going to plug it in. 100 equals 4/3 pi r cubed. Now I'm just solving for r. To get rid of that 4/3, I'm going to multiply everything by 3/4. You now have 75 equals pi r cubed. Pi is really hard to work with. You can approximate it if you want to. I'm not going to, because ultimately it doesn't ask me to approximate. So I'm going to take the mathematician lazy root out. I'm going to divide both sides by pi, so I get 75 over pi. And then to undo r cubed, I'm going to think of it the same way as a square root. However, instead of taking the square root, I'm going to take the cube root. And so that looks something like this. I still take the square, but I put a 3 outside. Some of you might be familiar with this. I just want to go over it for those of you who aren't. Whatever you do to one side, you do to the other. So it looks like this. And your final answer, because these cancel off, is just the cubed root of 75 over pi. And I have absolutely no desire to approximate that, but if you'd like to throw it in your calculator and get an answer, hey, more power to you. Go ahead, do that, absolutely. However, I am going to jump right into the key concepts. So, for any real numbers a and b, and any positive integer n, if a to the n equals b, then a is an nth root of b. So, for example, since 2 to the 5th is 32, 2 is a 5th root of 32. So that's a whole bunch of fancy words. However, let's just jump into working with the numbers. What is the square root of 16? Well, hey, we're pretty good at that one. It's 4. Technically, it's plus or minus 4, but I'm going to touch on that in a minute and why I'm only writing 4 down. The next one, remember we take the square root and then the negative, so this is essentially like saying 4 times -1. So my answer is -4. This one, notice it says plus or minus, so it's indicating specifically that I have plus or minus 4. And then, if you'll remember back to our imaginary numbers unit, the square root of a -16 is the same thing as the square root of 16 times the square root of -1. We know that the square root of 16 is 4 and the square root of -1 is I. So my final answer is 4i. But what about the following? What about, here, let's see if I can zoom in any further. Yeah, that's okay. So if I take the fourth root of 16, that is essentially asking me what number times itself 4 times is equal to 16. Well, there's no real easy way to think of this other than to just brain power it out. I know that 4 times 4 is 16. If I break that down one more time, I get 2 and 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this is x equals 2. Again, technically it's plus or minus. I'm not going to be doing that in this video until the very end when we talk about the idea of a principal root. All right, now we've got the cubed root of negative 125. Well, instead of having the fourth root where we have 4 things, this time we're only going to have 3. And you might be panicking a little bit because you're like, oh no, there's a negative inside. Here's the deal. The negative is only a problem in a few situations. And the most common one, the main one that we talk about, is a square root. Because there's no positive number that when you multiply it by itself can give you a negative. However, with the cubed root, because we're multiplying something 3 times, we can have a negative times a negative positive and a positive times a negative giving us a negative. So this one actually comes out nice. What number multiplied 3 times gets us 125? Well, that would be just the number 5. We just took the cubed root of 125. But it is negative. Negatives and odd numbers are okay. Negatives and positive numbers are not. So that might be something you want to log away. Now the next one, you're like, oh no, there's a negative, but it's a fourth root. I don't really know where to go with that. Here's the thing. The negative is a last minute thought. This just says that whatever answer we get for the fourth root of 81 is going to end up being multiplied by a negative 1. So if we put our x's out here, we need something multiplied 4 times to equal 81. Well, that's just 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So x is 3. That negative is an afterthought. That's my final answer because I have to multiply it by that. But it doesn't scare us when we're just dealing with the root. All right, last one. This one's got a plus or minus, just like the negative. It's an afterthought. Just deal with the root first. X, all of that equals 64. What number multiplied that many times? It's got to be really small if you're dealing with it 6 times. So this case is 2. Again, afterthought, add that plus or minus at the end, and you get plus or minus 2. So how does this work with variables then? We're pretty comfortable with numbers, but what about with variables? Same thing. You can still do the x method here, where you're taking x times x equals x squared. Well, that's true, so the answer must just be x. That's not a super hard one. However, same thing here. I have to multiply x times x times x to get x to the 6th. What would each of those x's need to have as an exponent in order to get x to the 6th? Well, since you're doing it 3 times and we know we have to add the exponents, not multiply, add, this would have to be 2. 2 plus 2 is 4, 4 plus 2 is 6. So our only answer would be x squared. The other shortcut for this is if you divide the inner number by the outer number, however many whole numbers, let me rephrase that. However many times you can do it with a whole number as your result, that's what comes out. Now, if this was x to the 7th, I would have x squared outside with an x left over inside. We'll see that a little bit more in a minute. All right, I'm going to stop with the x method that I've been showing you up here, and I'm going to just start shortcutting it. X to the 4th is 4 divided by 2, where my answer is x squared. Because all I'm doing is dividing my exponent out. Same thing with y to the 6th. Divided by that square, I get y to the third. And you can check my method with this if you prefer, but I'm showing you that's the shortcut and definitely would want to prefer to use it if I could. Where this becomes a little tricky is when you have non-nice numbers. Here's the thing. I can pull out an x squared here. I can say there's a single x. How did I do that? Well, let's go back a little bit, I guess. I can rewrite this inner piece as x squared x, and I'm even going to rewrite the y's at this point, y to the fourth y. Why did I do that, though? Well, because if I rewrite it with even numbers, specifically even numbers divisible by 2 here, nicely, x squared divided by x, I have an x that I can pull out. Now, there's still one inside. We'll deal with that in a minute, but this is what comes to the outside. Y to the fourth divided by that 2 becomes y squared on the outside, but I still have a y left on the inside. Well, just like I do when I simplify square roots with numbers, I can simplify square roots with x and y and other variables as well. And this is simply taking out the greatest common factor, essentially, with variables. So, I took out as many as I possibly could, and I left what couldn't be removed on the inside. Let's see that a little bit more. So at this point, with what little bit I've given you, I do want you to pause the video here, try these on your own, and then come on back. Be really careful when you're going through these because they're not all square and cubed roots. In fact, the first one is actually a fourth root. So try those on your own, and then we'll come back and go through them. All right, hopefully you paused the video long enough to give these a shot on your own. If you didn't, no big deal, we're about to go through them together. So with this first one, I'm still going to use that shortcut I found before. Dividing the exponents gives me whatever goes to the outside. So g to the 20th, the fourth root of that is g to the 5th, because I can just divide the exponents. Same thing with x to the 12th, divided by that 4, I get x to the 3rd. You can check me with the x method if you prefer. Not a real challenging one there. Let's go over to b. However, this one is a cubed root, so I have to be a little bit more careful. Even though I'm technically splitting them up when I do this, I haven't been showing you those steps. I'm going to do that now in case some of you are more visual. I'm going to split this up into the number and into the variables, just because sometimes I think it's easier to see. So, what is the cubed root of 8? What is something that multiplied times itself 3 times gives me 8? Numerically, that is 2. Now this is where it gets a little tricky. 8 is not divisible by 3, but how many times can 3 go into 8 nicely? It goes in nicely twice. So I have g to the 2nd on the outside because I did 8 divided by 3. However, I still have 2 g's left in here. So I'm going to change this to 2 to remind myself that they're still hanging out. M to the 9th is a little bit easier. M to the 9th divided by that 3 is m to the 3rd. 9 divided by 3 is 3. But remember, I've still got that g to the 2nd hanging out, so I'm left with the cubed root of g squared, which can't be simplified anymore because we can't take the cubed root of something that's only being multiplied 2 times. So, I know this kind of squeezed in here, but this is the final answer. I know this is going to make some of you mad that it ends up getting a little bit more complicated as an answer than it does as a problem. We're going to have to let that go at some point. All right, next one. This is a square root. The square root of 9 is 3. The square root of x to the 12 is x to the 6th. So my final answer is just 3x to the 6th. Boom. And if you want to check yourself here, you can actually square this whole answer aka take this, put it in parentheses, add a 2, and make sure that it ends up as the same thing inside. If you're one of those people that loves to check your work, it can be done with these types of problems. I encourage you to do so. Okie dokie. This one's a little trickier. This is a 6th root. We haven't worked with these a ton, but all of our methods still work. I have to find the 6th root of 128, and then I need to deal with the 6th root of c to the 6th and a to the 5th. Well, I know that 128 is divisible by 2 a number of times. In fact, I know that 128 can be rewritten as 2 to the 7th. So, one thing I can do here is factor out a 2, because I can rewrite this inside bit as 2 to the 6th times 2 to the 1 and be left with a 2 inside. So this becomes single 2, and then of course there's still a 1 inside hanging out. 2 to the 1 can be written as 2 as well, however you prefer it. And then simplifying this, c to the 6th divided by that 6 is just c. A to the 5th by the 6th root can't be simplified, so we're going to leave that a to the 5th inside, but it's okay. It has a friend over here with 2 to the 1. So I have to put all of my collective thoughts back together. Remember, the 2 came out, the c came out, and what's left over inside is the 2 and the a to the 5th. And then, of course, we have to put that 6th root back. I know that some of my thoughts are a little scattered. If you're having a hard time following along, I apologize. This is the method and the madness that I have come up with over time of simplifying square roots. If you find an easier method, not only would I love for you to use it, but I'd love for you to share it with me as well, so that I can always be giving new and better methods to my students. All right, let's keep going. Notice this one has 3c plus 2 to the 3rd. The same way that if we had x squared taking the square root, we know those would cancel. Oddly enough, the same thing happens with cubes and cubed roots. These two just cancel, and it essentially gets rid of the root. So our final answer for this one, without doing very much work at all, is 3c plus 2. If you see a root that matches its exponent, you should be very happy because the simplification is super easy. All right, last one of this type. Cubed root of negative 27. Remember, negatives are okay with odd numbers, less so with even numbers. What is the cubed root of 27? In this case, it's 3, and it's negative. So that's what comes to the outside. C to the 9th divided by that 3rd is c to the 3rd. Y to the 15th divided by that 3 is y to the 5th. That is the quick and dirty version of it with none of the work shown, but eventually after you practice these enough, you'll start to see those quick methods as well. All right, quick knowledge check. Let's see if you've been paying attention in algebra and algebra 2. Does the following work? X squared plus y squared square root, is that equal to x plus y? Here's the deal. Let's save ourselves some time and effort. Before we try to prove this mathematically, does or doesn't work, let's just plug in some numbers and find out. It's one of the coolest tricks I learned at college. And I think it's kind of sad that I had to wait till college to learn it. If I choose x is 3 and y is 4, these are completely arbitrary. I chose them without any reason. And I just start plugging stuff in. I have the square root of 3 squared plus 4 squared, and I expect it to equal 3 plus 4 is 7. Well, let's find out. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, the square root of 25 is 5. So does this equal 5? No, it doesn't. Why though? Why does it not work? Well, let's go back to what I was just saying was our favorite type of problem. This here, this 3c plus 2 cubed, where we took the cubed root. Now, if this was rewritten a little differently, for example, we had x plus y squared, and we were taking the square root, well, that would be true, because as I said before, the squares would just cancel off, and I'd have x plus y equals x plus y. But that's not the case. I have x squared plus y squared. And I know for a fact the x squared plus y squared does not equal x plus the quantity x plus y squared. And so whether you want to prove it by using numbers or you want to prove it with my little mental math here of just basic algebra stuff, doesn't matter. But at the end of the day, what I want you to recognize is that this doesn't work. Not legitimate. Do not use. So if you see two squared things inside, please do not simplify them to their non-squared version. In fact, let's just go over here. Let's write in big letters, do not do. My favorite phrase in the world. Grammatically unpleasant, but it works. Do not do. If you see something for, let's pick another one, 25, it does not equal 7. It's not the unsquared version of those things. This is the square root of 29. And let me tell you, folks, the square root of 29 does not equal 7. If you can't do it with numbers, do not do it with variables. All right, I'll get off my soapbox. Last things last. This is what I was talking about when I said earlier I wasn't going to deal with the plus or minus until the end of the video. It's because generally speaking, when we are finding roots, we use what is called the principal root. This is important to remember, principal root. It is the non-negative root unless a non-negative root doesn't exist.